Oh, okay.
Okay.
Sure.
So like I said, I've got a little introduction for everyone. So Research 101 webinar with myself from the Parkinson Association and Dr. Who. We're very happy that you were able to join us today. So thank you for your time. If you have any questions during the webinar, we'll get the chat box going so you can enter them in the chat. This webinar will kind of be a Q&A style, so please enter your questions in the chat and we'll get to them throughout the webinar. If you aren't able to use the chat box function, then you might be able to unmute yourself and ask your question directly. Just as a disclaimer, the webinar will be recorded. All of the information provided in the videos of Parkinson Association of Alberta and featured speakers is furnished strictly for educational and entertainment purposes only. This service is not intended to be diagnostic, prescriptive, or replace the relationship, advice, and/or care of your physician. General questions about symptoms, treatment, mentioned medications, complementary and alternative healthcare therapies, and current research will be fielded. So we'll do a little introduction for our guest speaker today. So Dr. Hu is an endowed professor for Parkinson disease research, Department of Clinical Neurosciences and Hotchkiss Brain Institute, the Cummings School of Medicine, and the University of Calgary. He has received many domestic and international awards and recognitions for his scholar work on brain networks of auditory learning and memory, language comprehension, and music perception. He was the founding head of Division of Translational Neuroscience and leader of two large translational research teams which developed innovative non-pharmaceutical therapeutics for Parkinson disease known as the Ambulosono Project, which I think you'll speak about next. So with that introduction, I will hand it off to you, Dr. Hu. Thank you.
Okay. Thank you, Ima. So can you hear my voice clearly? Yeah, very good. So first of all, during this pandemic, we have gone through a lot. Everybody, is that right? So I'm very glad many of our patients in the Parkinson community actually have done very well. So that set up us for the next phase. So some of you may have already been in this ambulosomal program before. You have experienced it, and the ambulosomal project is officially ended about 18 months ago. So as the program is ended, by protocol, we have to terminate it yet. Okay. So, but we have another project coming, like starting probably next month. Okay. Without further ado, I just want to give you a brief update about research we're doing, and especially for those new who are not familiar with the translational research we have been doing. Okay. One of your questions actually coming from patients is that how many type of research are there? Oh, there's all kind of research, is that right? So, but generally it is classified as basic, very basic research. Basic meaning is that you don't know whether this research will turn into be very useful thing. And actually, a lot of basic research do not get funded. No. For example, the mRNA vaccine for COVID, that research hasn't been funded for 25 years. There's only one single female lady who works at Philadelphia University. She just keep trying because she's very interested. That eventually led the mRNA technique and later take up by companies that develop vaccine. So the basic research initially, you don't know what will turn out. Okay. The second type of research is translational, meaning there are people like myself have done the basic research and came up with an idea and also a technology, and then trying to develop a new therapy. Okay. This is the research is most dangerous because 90% people fail because you understand something doesn't mean you can turn it to something useful. Is that right? And then finally is the clinical research. That's basically drug trials and etc. Okay, so you can't miss any part of these three major research. Is that right? So besides there's public health, epidemiology is also very important. So the ambulosonal research is a typical translational research that started from animal models. Actually, it's started from a phenomenon that was first described by Oliver Sacks about Parkinson patients. They somehow has a amazing response to music. Okay, so he described this phenomenon in his book, Musicophilia, and initially was in the film Awakening. Is that right? So he came to Calgary, and actually we have discussed all kind of music related Parkinson patients. So I have this impetus to study this phenomenon in animal models first, and then to see whether there's a chance we can translate it into a therapy. Okay, so the whole study started with animal research, like in 26, 2006. Okay, this is almost like 20 years ago. And then we created an animal model, and we noticed, the sound is not music, it's the sound stimulus can actually make the animal that are made Parkinsonian actually to walk again. Okay, so this is the sound stimulation to brain has a very powerful, it's a very powerful trigger for movement. And then in 2000, I think 14 or 15, the iPod Touch came online. Okay, so suddenly I have a technology. So then we developed this ambulosonal. Ambulo meaning walk, sono meaning sound. Okay, so essentially you use your walking to bring out the music. How we do it? So we have designed a sensor. This sensor actually can sense and calculate the size of your steps, okay, when you walk. And then it's connected to a headphone. There's music on here. And then once you finish your walk, and the data can send to our server, so we can visualize, analyze it, and change your training plan accordingly. Okay, so when you're doing ambulosonal, you put this sensor, okay, on a knee strap over your knee, and then you walk. So if your step size is smaller, let's say than 0.6 meter, you can define it in your phone, and the music will stop. Okay, for example, if you shuffle, which is very small steps, you're shuffling, there will be no music. But if you walk slow and with larger steps, and music will come out. Okay, so this is almost like a reward. If you make an effort, and then you will get music, and you will get motivated, and then you walk with larger steps. So over time, okay, you use it as an exercise, and then it's become a habit. So your gait function is reestablished during this reward conditioning. Okay, so I have a few video going down there that will show you how you can use music, ambulosonal, this sensor and apps for the purpose of treatment. So the first video is about this music walking exercise. So the patients actually use it at home. It's a very enjoyable. The longest patients we have is still ongoing in Australia. He walks something like 5 kilometers a day. It's very engaging. Is that right? So Calgary trials was actually there was 4 parties: University of Lethbridge, UBC, and University of Alberta and Calgary. So we total have like over 300 patients. Okay, and then later it's become international. So I'm just gonna play that video. And the second video actually is acute effect, just like Oliver Sacks described. somehow this music can help patients to overcome a freezing. Okay. The third video, it shows you if you have these low medications, for example, in the morning, and you do not want to increase your medications. Actually, you can use ambulosono to get out of this motor block to help you to initiate steps and walk around. Okay, so let's see the first video. This video, it was on YouTube. I have to take it out. This is made by the patient group because they don't want this music. We don't have the right for this music. Anyway.
At first glance, you would think these are patrons briskly walking into a state-of-the-art concert hall, excited to get the best seat in the house. They are excited, but this state-of-the-art facility is the University of Calgary. These briskly walking patrons all have Parkinson's disease. It's not Dean Martin they have VIP passes to see, it's Dr. Bin Hu at the U of C's Experimental Neuroscience Unit. Dr. Hu is taking brisk strides into the forefront of Parkinson's research, and he's using music to do it. His study focuses on the brain's ability to bypass the damaged areas and initiate movement with the aid of music.
So I have this idea about using the music as a reward and use their walking as the behavior and combine both to establish a positive feedback. When the iPod Touch 4 came out, like a dream device come true. So I designed this app called Gay Reminder, in which it sends each step when you walk outside and use that signal to trigger music play. If your steps is smaller than the threshold I set up, the music stops. So here you can see the patient wearing the iPod and he start walking. There's no music now. And now he start walking with larger steps and music coming directly from his iPod. And sometimes music shuts off because the step is a little bit too small. So patients have to walk larger steps in order to keep the music play.
I had heard some exciting research that was going on at the university through Dr. Bin Hu, and the preliminary studies were showing great promise for people that walked along with some of their favorite music. Before I started this study, I had a problem at the top of an escalator. I would freeze and I couldn't step on it because of, I think, of the movement, and it's downward and with the yellow lines. However, now I'm able to get onto the escalator with some reserve, but I can manage the escalator on my own. I think that is a positive. There was a point in time when before I started the program, I would walk, and then if I was tired, I could hear either Bruce or the kids saying, "Mother, step it up. You're shuffling a bit." And so I would do that. I don't hear them say that to me anymore, which is great.
I think since I've become part of the program, it gets me outside walking, enjoying nature, enjoying fresh air, and listening to great music while I walk each day, and feeling very positive. Sometimes it's difficult, even making time for a half-hour walk, but I try to make it part of my daily routine, and it has become part of my routine, and I thoroughly enjoy my walks now. What if the next step for Parkinson's treatment is just that? A step, and then another, and another, and another.
Take the next step! Get walking!
Well, it doesn't look like Parkinson. Okay, sorry. I'm going to say a few words about this walking exercise. Number one, so we have tracked something like 50 to 70 patients. They walk anywhere between 3 months to 6 months, and we follow them for 2 years. So their UPDRS score is substantially better than the patients who were in the program but walked very little. Okay, this may be either because they have a injury or depression. So this is as a control. So they're actually the improvement. Their UPDRS score is decreasing. Is that right? So usually, disease progresses, you're getting worse, UPDRS rate is increasing. So there seems to be a slowing of the depression, the progression. So we do not know for sure yet, because we'll need a larger randomized control trials, because we don't have a placebo controls. So we don't know it's music or it's exercise or it's the both. Okay. So secondly, there are brain imaging. Brain imaging shows very dramatic changes in area that controls your walking. Finally, there are some anecdotal cases. Patients use it for arm swing training. They put it on the arm. So once you swing your arm repetitively over time, the arm swing or lack of arm swing in these patients, actually, it seems like a permanently stopped. Even you stop training, it didn't come back. Okay, so this led us to believe there is some effect about this therapy. Actually, it does actually slow down progression, may reverse some symptoms related to the motor control. Okay, so the next video is showing the a typical shuffling and freezing. Okay, so this is in Melbourne, so neurological clinic. So this lady, have fear of falling. Okay, now she only had Parkinson's for 5 years. So her walking is so bad, she always constantly fear about falling, so she has to use a stick. Okay, it's very painful. 5 years ago, she was a advertisement company executive. Everything was normal. Okay, so when she get into the narrow space, especially this door, okay, you see, she hesitates, almost like trying to fall. Okay, if you ask him to stand up and go and turn, you see, so very, very small steps, okay, and leg trembling. So this is actually, she used ambulatory device in the hallway, just walk back and forth, with the headphone on, and she can get music play. In the middle, like 12 minutes later, she just threw away the stick. Now her walking looks very natural. Is that right? So the arm swing is there. See, once she went through the door, there's no freezing. Okay, and so repeat and okay. So we now have probably over 150 patients who did similar test. The responding rate is over 80%, meaning that if you do 10 patients, 8 patients will respond in this way. Okay, so this is quite effective, in terms of as a therapy. So the last video is a Calgary patient. Oh, sorry. So this is not wrong. Okay. So this patient actually, this is in the morning, in a way that her medication is off. Okay. So she couldn't lift her leg. You may all experience this or later in the Parkinson's disease. Okay. There's no arm swing. Okay. So every morning she's like that when she gets up. It took maybe 40 minutes to walk to the kitchen, unless you take your pills, of course. So this is
trying to get music play.
So
okay?
she's wearing the device on her left leg. So this is just steady.
Higher, yeah.
You have to step in higher for the music to come up. See the arm swing comes back.
Almost done. Very good. So how about you think about when you were stepping with the music? All right.
Yeah, this is a post training.
Look at this. Is it magic?
It's magic. It's magic.
Close your eyes. Think about your stepping.
Yeah, she can walk in the small space or going out, like say for half an hour to 1 hour, okay, and then the freezing came back. So then you have to redo the training, okay. So she basically responded so well. She's called it ambulosonal pill, okay. This is one of the response also has a very dramatic outcome, okay. So let's see what I have next. Okay, so that's the video. What do we have? So this last slide, I want to briefly mention that. So the new project we're going to do is called XCON, to Access Connect. So this is a project is going to start from November this year to next year. It's supported by Alberta Health. Okay, so this is a home-based NGO managed sort of a mental health responding system for combating COVID now and the future. Okay, because patients stay at home, they need a technology, they need a service platform that is effective. Okay, and then they can use it. You don't need to come to the hospital or clinic. So you can engage in rehabilitation training, exercise, medication adjustment, social support, and etc. Okay, so that's why we want to train the so-called NGO manager. We want to train health coaches from different NGO organizations, so then they can take on the task. So to implement this platform. Okay, thank you very much. Now I take some questions.
Okay, thank you for sharing. It's amazing to see the research that's already been done with Ambulosono and just from those videos, how it can impact somebody's walking. It's amazing to see. The Access Connect project that you mentioned, that will be available to anyone in the province. Is that right?
Correct.
In November. Okay.
Yeah.
And we'll be sure to share that with everyone closer too. So we have a couple questions just about research. Some of these were submitted beforehand, so we'll kind of go through the list and you can answer them. So you mentioned how research gets funded, but it does take some time and especially time for the results to be available to the public. What would you say the timeline of research is from starting idea from that researcher to available to the public?
So in terms of pharmaceuticals, I guess this is the typical one because all the other ones, they're very variable. So the normal term is 10-10. 10 years, $10 billion. Okay.
Oh, wow.
so that's actually the optimal estimate. Sometimes it takes much longer. There's many reasons for it. Is that right? So, for example, you have seen in the news, there's this new treatment, there's new medications, and these cancer drugs works on Parkinson's. But all those studies may be true, okay, but they all have a hard time to translate it into a random controlled trials, which usually require like thousands of patients and a lot of money. For drug companies, they don't have the resources to test each drugs. Actually, their top priority is to eliminate medications that may not work, or when they work, they have no market for them. Okay, so that's why it's very tough for non-pharmaceutical research like the ambulosonal. I feel very fortunate because it's very difficult to get funding, but the ambulosonal program probably is the only one in Canada has been funded for a consecutive of 10 years, federal government, provincial government, and etc. because there's a real benefit to patients. So for non-pharmaceutical interventions, this is my personal opinion. And this is also why I designed the XCOM. I think in the future, it should be faster because we know the risk factors or the side effects can be very well controlled. Okay, so you need a new way of doing this type of research. Maybe, for example, if we want to study dark chocolates benefits for Parkinson's or for dementia and whatever, we can just let patient take it and then have a tracking system through these health coaches. Is that right? And then we don't need government funding. We just need the patients to participate. And if there's no harm, someone supervise. Okay. Yeah.
Okay, thank you. I think a study involving dark chocolate, you'll have lots of people signing up.
yeah, that's a good one. Yeah.
Yeah. So one of the other questions that's kind of related, in the news, we often hear about drugs that are showing promise for a cure for Parkinson's, but it's usually in mice that they're testing the drug at first. So how does an animal model translate to human use? And is it the same timeline? Is it that same kind of 10-year timeline you were mentioning?
Yeah, actually, it is much longer, especially for, like, say, the mouse. Is that right? People use different animals. There's monkey, dogs, and rats and mice. The reason there's a lot of mice study because you can manipulate their genes. Okay, and for example, you knock up a few genes, the animal develop Huntington disease, one or two. For Parkinson's, actually, there are models. You can produce Parkinson mice or dementia mice. Okay, so why the drugs on these mice looks promising and sometimes actually can be cured, but we can't translate it into human. So there's many different reasons. Okay, first of all, a primary reason. This is my personal opinion because when the animal researchers use the mice, it's almost like they're identical. Okay, the mice grow in the same environment. They come from the same strain. They eat same thing and live in the same cage. But when you come to human, we all come from different environments. We eat differently. Our system is very differently, right? Besides, our brain, is 80 times bigger than the mice. And secondly, I think that there's also, it's not the science was wrong. Okay, the basic science, when you develop an animal model and you show an effect, it's not wrong. It's just in human, there may be additional, compensation mechanism, or the mechanism is a little bit different. Okay, so for example, there's antidepressant medications. It was like it works perfectly in animals, but doesn't work in human. Later on, they did a genome sequencing. So there's one gene is different on the serotonin receptors. So that's why that medication didn't work in human. Okay, so how are we going to solve this problem? There's a tremendous research now to use patient's own cells. Okay, you can take a skin cells from a patient, and then they have this stem cell property. So actually they can grow, multiply. So you have your own organ actually now can be in the dish, even brain, okay? So that is a very promising model because the genetic makeup is you, is you yourself, okay? So this is very promising. But again, how long it takes, we don't know, okay? This is a question I think could come up, how long it takes to research to actually get a cure. You think the vaccine is quick, 6 months, you know, why you can't find a cure for Parkinson's? Okay, you know how long the vaccine actually being developed? It's over 20 years, not 6 months. 6 months is that they totally already been, it's working, and then nobody cares about vaccine research, and suddenly we have COVID. And then they go back, the technology is already being developed. So they can actually use a technology that being researched for 20 years and then develop vaccine in humans in 6 months, okay? So the vaccine is not, you know, just born overnight, no.
Okay, thanks. And then one of the other questions is we hear a lot on the internet, sometimes on Facebook or YouTube, in magazines about different treatments and cures for Parkinson's. So some common ones we've heard is the use of medical marijuana for Parkinson's, or different diets like the keto diet. There's always different research that's coming out. How do people with Parkinson's know what is true and real research versus what's maybe a myth or what's fake research that won't benefit Parkinson's? How do you determine?
This is a very good and it's a very important question. You know, personally, I have often seen the patient come to ask me, and I have even seen patients spend $8,000 bought a magnetic match because someone told her that this works, and etc. Okay, so the way to approach a treatment that you heard on the street, okay, is this. Number one, you have to have a backup mechanism. Okay, whenever you purchase something, okay, I'm talking about equipment. Okay, there are many them on the market. You need to have a try period, so you can try on yourself. It may work on somebody else, but if you find it doesn't work for you, you have a mechanism to return it. Okay, do not sign anything saying, okay, this is not a returnable. Okay, because the chances of any of these equipments that works for you is very low. Okay, and the secondly, we do not know. Okay, I can't tell you. For example, marijuana, weeds will be good for you or not, because there are many small studies says yes, and there are also some studies say no. So the latest view is that you will not be able to expect your physician to prescribe it. Okay, you can buy some in the store and try on yourself, but make sure it's safe. Okay, I personally don't say don't touch it. Okay, because sometimes you need to touch it, and then you get convinced yourself whether it's working or not. For pain, we know marijuana for pain works. If you have pain, you have Parkinson, you know, because of dystonia or things like that, you can try. Okay, very small amount. Maybe you got to go to talk to your family doctor. Okay, before you try it. For pain, we know there's a beneficial effect. Okay, for something like somebody mentioned the Trimmer Miracle. It's available on Amazon. You can buy them. If you read the label, those are, you know, mainly vitamins. You know, we know vitamin B12, for example, is very beneficial. Okay, so those supplements are okay. I don't think it's going to harm you. Okay, especially if you read labels, make sure you Google it, see there's any side effects with these components. And lastly, about coffee, is that right? So this is how hard the research is. So people have a lot of experiences, and there's a lot of news in the media, and the coffee can prevent Parkinson's disease and slow it down. Okay, so there's a trial, including in Calgary, over 24 months. Now you have controls, you have coffee group. There's no difference. Okay, and then there's new study came up just like 6 months ago. It turns out it's not coffee. You have to eat coffee beans. The coffee beans have this wax. That's the component in the wax actually is beneficial. So, things like that. Is that right? Sometimes you heard a vitamin helps and then the other says there's no effect. It's because, you have to be very precise to know what actually is helping you what or not. So anyway, so the bottom line is if it's a safe supplement, dark chocolates, vitamins, by all means, okay, make sure you don't overtake it. Don't spend too much money on try it. For equipment, make sure you have a backup mechanism.
Okay, yeah. I think you highlighted a couple important things. Make sure you're doing your research and looking for trials. Make sure your healthcare team is involved, your neurologist, your family doctor, anybody that's a part of your health. They need to be involved if you're going to try these things. And yeah, make sure it's something that's safe for you, like you mentioned, those supplements or yeah. Okay, thank you. One of the other questions is about research and sharing research. So is research that's happening across the province or in Canada, is it shared with other researchers? Do people work on things at the exact same time?
Yeah, I think this, if you back to 20 years ago, we probably, I can't say everybody is sharing with everyone, is that right? But nowadays, it's the information explosion. There's too much information. Okay, there's too much sharing. I don't think it's less because people publish their research, and that is the most effective way to share. In Calgary, we have a different theme of researchers in Parkinson's. Okay, like myself in these ambulatory treatment, and there's imaging, and also there's a team that study pain and sleep and etc. Okay, so but again, you have to understand what the research means. Okay, the basic research, the translational research, the clinical research. Why is it so hard to come up with a cure? Even L-DOPA. L-DOPA took probably at least 15 years after they were discovered. In animals, they saw that it works perfectly until they tried in humans. Is that right? And it's not a cure. If you asking me, what is a cure for Parkinson's? So a cure will look like you did something, or a medication, or exercise, or whatever, and then you go back to the brain, and you see your brain stop losing dopamine. Actually, you're gaining dopamine. Okay, so that's definition of a cure, because the primary cause of the disease is eliminated. Not the cause of the disease, but the symptoms of the disease. Is that right? So the ambulatory, the treatment, this is what we think, because over time you develop a compensatory mechanism, because there's this dopaminergic system. It is not used for control walking. Okay, and then during ambulatory, this system can be trained and then used for control movement. So the idea came from a monkey. So the monkey, there is a monkey model. If you make some Parkinsonia, like 60% of this monkey actually spontaneously recover from Parkinson's. So when this French group, they look at the monkey's brain, they saw this compensation, serotonin or dopaminergic pathways help this monkey mask their symptoms. Okay, so that is actually very close to a cure, but it's monkey, unfortunately. Yeah.
Mm-hmm. Okay. Do you know if there's any research in Alberta that's being done towards a cure or towards finding the cause of Parkinson's?
But there's probably close to 20 also, Parkinson related researchers. Everybody think they're toward a goal to cure the Parkinson's, but in reality, most of this research is still a treatment. Yeah.
Yeah. Okay. And then another question is there any research being done into early intervention or prevention of Parkinson's?
Exercise. Yeah. I think the most convincing evidence out there is if you, for example, you walk like so extra time over these 2 years or 5 years, 10 years, the probability of you developing Parkinson's is very low. Okay. The second type of research is to look at some certain type of medications. For example, there's this medication treating asthma. Okay, so if you have asthma, you took some beta receptor agonist, and it turns out the patient take asthma drugs, they have a way less chance of getting Parkinson's. Of course, I think you probably asked me the smoking, right? I don't think smoking is a good idea, and also it's not confirmed. There's no really firm evidence. Okay.
Okay. And yeah, you mentioned exercise. I just want to make a little plug for the Parkinson Association. So if you or your loved one has Parkinson's and they want to get involved in exercise, we've got a range of different exercise programs across the province and some virtual ones that you can join on Zoom at home. So lots of opportunities to get exercising if you want to. Okay, we'll go to some of the other questions. So someone who's joining us today actually participated in Ambulosono previously, and they are wondering if it's possible to get involved in the next phase, and if so, how do you do that?
Yeah, I've been asked. I know I missed all my patients in the Ambulosono program. We had so much fun. Is this I need to go back to whoever participated in Ambulosono. Okay, and then we want to carry out a survey because some of patients we have tracked, they're doing very well up to this date. So the way we want to compare them is same age, same sex, same year of disease. See, actually, they're doing better. Okay, because we believe this indeed there is a beneficial, long-lasting beneficial effect. Okay. Secondly, if you did Ambulosono when you were 60s or you're 65, so if you are 70 now, are you going to still try? We don't know. I can let you try, but I'm not sure it works on the brain, after so many years. Is that right? So we have to reassess your current condition. Especially, we want to know whether there's a freezing, you suffer from now, okay? Because some of the patients actually use Ambulosono very frequently. 5 years after that, they haven't developed any freezing, but in the regular clinical situation, usually within, after 10 years, you really have some kind of freezing. Okay, sure. So bottom line is that if you participated before, we will accept you again, but we need to do a little bit differently this time.
Okay, that's good to know. And then we have another question about participating in research. So if you're in the main cities like Calgary or Edmonton, usually there's research you can participate in there. For folks who are maybe not as close to a center, who are in other parts of the province, is there ways that they can participate in research?
Yeah. The Ambulosono, one of the strengths of the Ambulosono, one of the province wants to fund this here. It's the device. You have the device, and you can do this exercise remotely. Okay, and then your data is transmitted to us through Wi-Fi. So we know how well you're doing, okay? So the challenge will be, number one, you have to find a suitable place to walk. You know, when weather is good, you can walk outside. But weather is not good, you better find a gym, you know, a gym on the, you know, indoor to walk. So the answer yes, you know, remote, if you're living outside, because we had a patient all over the place, is that right? So all the, you know, Vancouver patients actually transmitted their data to us. So
Oh, okay. That's good to know. Okay. One of the other questions is, can I donate my brain and or body specifically to Parkinson's research?
I have to get back to you on this question because
Okay.
latest like I heard is that we haven't have a brain bank set up in Calgary, but there's one I think in Regina, very good one. So
Okay. 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 And then the last question that I have here is, usually research is, when we think of research, we think of a cause and a cure. Are there other types of research? And if so, how many different types?
oh, so you know, for Parkinson's, you need to know, you know, if you have a you already got Parkinson's. Okay, if you don't get, you know, the prevention and etc. If you already got Parkinson's, the pharmaceutical treatment is essential. Okay, don't wait. Okay, and secondly, the exercise. There's also there's a nutrition, a certain nutritional scheme can be very helpful, and social support. Okay, I can't emphasize how important it is. So join the Parkinson's Society, you know, when you have a group of patients and you can exchange information and etc. Don't just stay at home by yourself, okay? And finally, I think you need to realize the social support aspect also include like your disability benefits, is that right? So how you work with, you know, with if you work, how you arrange all these things, okay? So there's many different type of approach. A DBS, for example, okay? So now we have a duodopa, you know, these are the intestine injected medications. It is with smooth, okay? So you induce less dyskinesia or wearing off. For DBS, it's very good for dyskinesia and also other symptoms. So the treatments actually comparing to a few years besides medications, we have a lot. Yeah, you know, if you read, there are also people saying, no, there's this new air stimulation you wear on your ear is non-invasive, actually helps patients a lot. So there's many different kind of non-pharmaceutical treatments, actually way more than the medications, but it hasn't been tested, rigorously. Yeah.
Okay. And one of the other questions was, the levodopa medication has been the gold standard for many years. Do you know if there's a new medication on the horizon, or are they?
Yeah, all the medications we have so far, okay, every drug is comparing to L-DOPA. So that's why they call L-DOPA is the gold standard, the front line. In terms of treating motor symptoms, we haven't come up with a medication that is better and convenient to use than Cinemat. Okay, so there's many dopaminergic agonists, but they are used for different purpose, and there's a managing or whatever. But in terms of motor symptoms, L-DOPA is still the best.
Okay. And then this one I'm not too sure if you'll know about, but there's been some talk about focused ultrasound therapy. It's being used for other conditions. Do you know where it's at for Parkinson's, and if it's something that could be used for Parkinson's?
Yeah, don't listen to the hype. We had a meeting, I think, 2 weeks ago. I don't think there is confirmed clinical study, meaning large number of patients and etc. Even suggesting it's beneficial. Okay, so we have a long way to go. Now we have our focal ultrasonic group here in Calgary, but we haven't at a stage even to start a clinical trial. Yeah, very,
Okay.
very minimum evidence so far.
So still a long way to go. Okay. That was all the questions that I think I had. I'll just give folks a minute or two to type in the chat if they have any more. And I guess while we wait, Dr. Hu, is there anything else that you wanted to share about research that you have ongoing or?
No, it's all there, but I'll just encourage patients that, you have to be active, do not, if the more you become isolated, especially during the COVID, the more, not depressed, but your symptoms are getting worse. Yeah.
Yeah, I would definitely agree. Reaching out and making some social connections is always great. And if you're not sure where to go for that, then you can contact the Parkinson Association, and we're always happy to help with that. I'm just looking at the chat box here, and I don't see anything else. So maybe this is a good place to kind of wrap up. So thank you, Dr. Hu, for joining us today and taking the time to share your knowledge. We truly appreciate it, and it was great to hear all of the research that you've done and that you have going on. Thank you to everyone who attended and who was able to share some questions. We hope you can join us at our next scheduled webinar. It's coming up in October. It'll be with Tim Hegg on PD Avengers. So for more information, you can go to parkinsonassociation.ca or follow us on social media or call your local client service coordinator. And then all of the webinars are recorded and shared on our YouTube channel. So if there's something that you want to go back to, you can always go back on the YouTube channel.
All right.
Thanks, everyone.
Okay. Good luck, everyone. Okay.
Thank you, Dr. Hu.
All right. Terry, I will connect you later. Okay.